of the equipment we currently have, and then why don't you take a leap of faith there and talk about some of the wish lists
Okay.
that you have of things that you want to have here in the lab.
So it would be great to have a couple sponsors to provide some machines that'll fill out some of our gaps that we currently have. But right now, what we currently have is we have laser cutter. It's my favorite. We have a couple 3D printers. We have some resin printers. We have some reflow ovens and some solder masking things. We have a soldering station. We have vacuum formers, and then we have a little bit of software server stuff. So we're building some servers out to do some more actual software maker hacking type stuff that I'm pretty excited about. But things that I would love to have, power supplies, old scopes or new scopes, function generators, battery simulators are another really good one to use, especially when you're making things that have batteries in them, right? To test, the longevity or the charging cycles and kind of analyze how your device that you're making will interact with it, right? What happens when you get a brownout, stuff like that. CNC would be really nice to have something that's at least contained.
For the audience, CNC?
CNC is essentially a 3 to 4 axis drill, right? And you use it to cut out different pieces of either wood or metal, machine parts, and it's all computer controlled. So you use a CAD software, design a 3D model, and then generate a tool path using G-code, very similar to how 3D printing works, except instead of extruding material, you're removing material, so subtractive manufacturing. So those would be a couple good ones, honestly.
Okay, no, that's wonderful. So one of the things that immediately comes to mind, this is for the parents that are watching online and the parents that are here. Early in my career, I started, well, that wasn't that early, but a few years ago, I was working in the late 90s with early 2000s with Hewlett-Packard, who eventually became Agilent, eventually became Keysight. But everybody knows the story of Hewlett-Packard, at least in the tech world, of Bill and Dave and what they did and how they changed the world with test and measurement equipment. What a lot of people don't know is this story. If you can imagine, in the 70s, we had these things called phone books.
What's that?
Right? We had these things called phone books, and a young man in the 70s, high school student out in California, because of course Hewlett-Packard was in Palo Alto, still is, had a science project, and he needed basically a makerspace, but they didn't exist back then, right? So what he did is he picked up the phone book and looked up Bill Hewlett's phone number, which was listed.
That's crazy.
Yeah, imagine, right? So this is like one of the top geniuses in the world, and his phone number is on the phone book, on the white pages. He proceeds to call the man, identifies himself and said, I'm a student at high school, whatever. I have this project, and I was wondering if somebody in your company can help me because I'm stuck. And Bill proceeds to tell him to come to the office tomorrow. And he actually meets with him, right? Gives him a tour of the facility. I mean, imagine for a high school student, at the time, and then introduces him to a bunch of the engineers. And Hewlett-Packard had a very interesting philosophy, and Agilent and Keysight still do, where they had these labs where everything there was for you to just play and bring your kids and do your science projects here. And if you have a thing that you want to build at home, build it here, right? And everything here is, don't go commercial with it, but just play and be creative here in the office, right? So he took him there and he introduced him to a bunch of engineers, and they helped him out, and that person was Steve Jobs.
That's great.
Right? So maybe the next Steve Jobs can come through this space here.
Maybe.
And we need the parents that are watching online and the parents that are here to talk about this. We have a parent over there already nodding, right? About this, because I think it's important for the community here at Lake Nona to know that people like you are trying to do this, and the importance of what this can do for a young mind.
Exactly. Yeah, no, I know that Lake Nona has a strong foundation of smart individuals and makers, as evidenced by the Charlie Brown Christmas thing. I don't know if you went over there, but they had these nice 3D printed Snoopy's dog houses, and they had a microcontroller. I just kept looking at them. I didn't even look at the houses. I was just sitting there peeking through the little dog hole in his little house, looking at the microcontroller and the speaker setup, and I'm like, what are they doing here? So we definitely have a strong community. I think this will kind of, bring it all together, right? Just as you're saying in your story, that's like the prime example of collision ability. And so I think the same thing, you need the lightning rod to attract everything.
Indeed. So we have a couple of little toys here that
Yeah.
that I wanted you to kind of go through just to give an example. This is, again, just one example of what it could look like, right? So we go from the very, very early stage to what it could potentially be. So why don't you just give us a little bit of a background on what you have here for show and tell?
Yeah, so all of these are electrical themed, right? We actually have a lot of other things that we can do. One of my favorite workshops that's not like this is engraving glasses, like cups. It's one of my favorite things, just as like a gift. You go to Goodwill and get a couple glasses, engrave something silly on them. Your own custom glass. It's fun. But we have a few different stages of development and difficulties here. The first stage is a soldering workshop where you just do some through-hole component soldering. I think this one here, you're just making some flashing lights that you can adjust with some potentiometers, right? This one, most people can do, right? It's just learning how to actually solder, do it correctly, learning correct, good habits, right? And then from there, we kind of move on to your classic breadboard. This is a project that actually helped a kid named Bronick build over here. This is going to be a goal tracker for anytime Messi scores a goal, it's going to tick up the numbers here. So he's a soccer head. And then we have a few more extra parts here. This is kind of the next stage. This one here is I was messing around with this is an SSD 1306, so I don't want to get too nerdy, but it's just a little LCD screen.
It's too late for that. You know that, right?
Yeah, you're right. And yeah, just testing it out with doing some graphics on this little 8-bit microcontroller called a DigiSpark. These things were like my bread and butter back in college because they were like $1, and you could put them in pretty much anything and not care about them, and they were pretty easy to program. It just does like a little 3D simulation of a cube. I built this one, same idea, except this is kind of transitioning into our next topic about technical creativity, right? I had a laptop I was doing a lot of development on, the space bar just died. Couldn't really fix it. I don't want to get into it. But I need a space bar to type words and everything, right? So what I ended up doing instead is I got another one of these same little DigiSpark micros, and I go to CES every year. And I got this sample of a keyboard keycap, fully functional. So I just plugged it right onto the DigiSpark, mapped it to type a space bar every time you push the button, and now I have a space bar again. Now it kind of seems like you're typing with a typewriter though when you're writing, because you're like,
Yep.
So that's kind of funny.
But it works.
But I also do technical consulting and actually problem to product prototyping. So I have a couple clients, and I have some client boards. This is a development board. This one here is, you blow it up, you make it really big and wide, and you add as many test points, and you sort it and you clean it up as much as possible to be able to debug it. So this is a debug board for a product that one of my clients is working on. And then once you go from this stage and everything checks out, then you move on to smaller, really tiny prototypes like this one here. And I have other dev boards for other problems and products over here. And then we have a Raspberry Pi, which this is a full-blown computer. I think everyone has heard of those.
Just for people to get an idea of the timelines that this takes, so like you mentioned, the bigger board, you go from proof of concept, then you go to prototype, and then once the prototype is working, then you create something that's more miniaturized.
Yeah.
Right? At least in this area here. And these days, you can submit a board design to a board company and have your boards be shipped to you in no time.
Yeah, well, it's like a week, and it comes from China, or at least that's where I get my boards fabbed. It'd be nice to find a local one that's even faster, but they're hard to find good fabs that can do small batch custom orders like this. But I mean, the development process starts, you sit down and you just draw on a whiteboard, right? You talk about your problem, you talk about what would solve your problem, what exists out there, right, in terms of either existing products or sensors that you're going to use to understand what your problem is and how you're going to solve it, right? So we kind of step through each of these stages, right? You throw everything on a breadboard with a development board, and you build out the problem or the product, make sure everything functions from a concept. Then you make a smaller, more compact version. This one's optional, honestly. Once you go to breadboard, you can kind of go straight to prototype board. But you do something like this. Then you have a dev board made once you've written some software and you know everything works and it's going to work. Then you spend some money and you go get a board done. And honestly, a small batch of boards really doesn't cost too much. If you're gonna make a product, you could do it for, between 200 and 100, even lower if it's really small, right? So you make this design for something like this. If you've never done it before, it's going to take you a few months because you're going to be researching, understanding every single area of the process, right? From actually how to program microcontrollers to power management to communicating over the USB bus, depending on your applications, right?
That's if you're doing it on your own. If you're in the makerspace,
exactly,
then it's not months, right?
It's going to speed you up a lot because people are going to say, oh, hey, this you're going to need boot and reset buttons, right? That's something, if you get stuck or you need to put it in a boot mode, you're going to need that, at least for ESP development, right? And it depends on the architecture of all your stuff. Once you've got your prototype board, then you kind of move to final product, where you have your much smaller, custom shaped, everything's crammed on here and you're running out of space. This is where you can actually start taking this to investors and say, hey, I have a product and here's what it does, and you can show it to them and it works, hopefully. Mm-hmm. So that's kind of the entire process.
So what is the timeline here? I mean, are you fully operational now? I mean, are you having people? I mean, I know that I've seen a few kids over there with you already. What stage are you in right now?
We're like soft launching. So right now we're working on getting all of the machines up and running, because what we want to do is provide a place for people to donate machines, right? We have a couple different donors that are really generous that we give them access because they leave their machines here, and we take care of them for them, make sure everything's working and it's up and running and there's access to them 24/7, right? So we've been soft launching that, making sure everything's working. So within probably a month or two, everything should be up, good to go. That's kind of the time we're looking at.
Tell people about your junk pile.
Oh yeah, so hopefully towards the end of this year, we are going to do some hackathons here. Mm-hmm. Most of those are more software based, but I am a hardware guy, as you can see, and so I'd like to put something on called a junk jam, which involves junk. Essentially, old blenders, printers, ancient laptops, salvageable LiPo batteries, drills, power tools, stuff like that, right? We'll just throw them all into a big pile. I'm trying to figure out the criteria, if we should solve a problem or if we should just judge it by creativity or what it does, or if they should battle each other or something. So that part's still in the air. But yeah, you give them a weekend, give them a pile of junk, and say, let's make something fun, exciting, artsy. Who knows?
Well, you're already doing that, right?
Yeah.
I walked into the office today and we had a monitor that had died. And he took it apart, and now it's an additional lighting, part of the lighting system in the podcast room that we have over here behind us. So there's an example of taking something and not throwing it away. It still works.
Yeah, reuse is another big part. So, donating old things that may still be completely functional, or less functional. There's still lots of usable parts there. Like if you have old charging cables and stuff that, I got the new iPhone. It uses USB-C now, which I'm a fan of. But you have all these old cables, right? They're great. They got USB on the end. You cut it, you open up, you got USB access right there, right? You can plug whatever project you in right into a charger. Perfect.
Excellent.
You don't have to throw out as much stuff as you think you do.
Excellent. Well, I wanted to open for questions. I don't know if we're set up for questions right now, but you're going to be here, for the rest of the evening.
Yep.
We have another guest coming up, and then, if you have questions for Austin, please. Yes, go ahead.
Best first project for an 8-year-old. Ooh, that's interesting. It's gotta be something that they're interested in, right? You can't just say, oh, here's a project and hand it to them and say, do this kit that I got online. It's gotta be something that solves a problem or something that they're passionate about, right? You have to take the skill level into account, but if it solves a problem that they're interested in, or if they, like a doorbell for their bedroom or something, right? Something simple that exposes them to a lot of different steps of the process, that kind of dips your toes in the water and exposes you to every little piece while not being too difficult. My first maker project when I was like 6, I got a cardboard box and I stuck straws in it, and I called it a soapbox air conditioner.
Oh.
You just blow into it. It didn't do anything, right? But that was kind of like the spark of creativity. And then it's like, maybe I should take that radio apart. It's looking pretty nice over there. And then we kind of went downhill from there, right? But my first real project that I actually did was, it was right when Raspberry Pis first came out, the first gens. Mm-hmm. And people were experimenting with them. I was one of the first Raspberry Pi arcade machine makers. So there was a guy, Shay Silverman, who actually was kind of showing off his whole development process. I was in high school at the time, and I was like, oh, this would be cool. I always wanted my own arcade machine, right? And so I got one of the Raspberry Pis, and I was going through all the steps, right? And then you're hooking up the button boards, and you're connecting it all to, CRTs and everything like that. And you really go through all the steps. I ended up using it as my senior design project for high school. But yeah, shout out to Shay Silverman. I don't know what he's up to these days, but something cool.
I'll tell you a good project. This was years ago. I was doing mentoring for elementary school kids with Agilent. They had a really good educational program all over the world, and I was at the time spending a lot of time in Scotland. And this little 8-year-old was interested. He had a lot of siblings, and he liked his privacy. So we helped him build a motion detector sensor for his room that would trigger an alarm, right? And would trigger a number of different things in the household. So I don't know if you have any siblings, but there's a project for you.
Yep.
So what do you want to, 3 things you want to leave the audience with as we wrap up?
Okay.
Some call to action, some action, some challenges. Let's get these people to do something. Come on.
MS2 makerspace. It's happening. I'd love to, if you have machines in your garage that are gathering dust because we don't have basements here and you can't use your machines, I have a place for you to be able to use your machine. It'll live here and be nice and happy and clean. Come drop it off, and you can come by and use it whenever you want, right? 2, collisionability, right? Focus on being open-minded, talking to people who are much younger than you or much older than you, and realizing that everybody brings something to the table, whether it's creativity or, skills, knowledge of certain machines and expertise or business. Everybody has something they can bring to the table. And number 3, have fun. At the end of the day, this is a fun hobby or line of work, hopefully, that you can turn into something useful. Have fun, enjoy what you're doing. there's been a lot of times where I've been working on projects and it really gets to me because something should be working and it's not working and you don't know why, right? One, turn to your community, get some feedback, but also if you need to take a break, don't be ashamed of putting something out on the table and maybe coming back to it a year or two later. It's totally fine. It's totally fine. You'll be older and therefore wiser.
So has the term junkathon been coined yet?
No, not yet.
No, there you go.
Maybe we'll do junkathon.
Junkathons. Yeah, let's do that. Well, thank you very much, Austin. This was interesting. I thank you for those of you who are here. Thank you for everyone online. I appreciate what you're doing for the community. As you know, I'm passionate about getting people together and connecting in this collision ability that you talk about. I'm definitely going to use that term because we need more of that. We have so many good people in this community. So many people that can, if a fraction came together, what amazing things, beyond the amazing things that are already happening here, we could be doing. So thank you all for being here. We'll see you next time. Thank you, Austin.
Thank you.